Hello and welcome back everyone. In this video, we are going to solve a few questions from the topic mole concept. The questions we are going to solve are a bit tough questions. These questions are challenger questions. So let us begin. So before going to the questions, let us take a quick revision of mole concept. So in mole concept, we actually use these three main formula. These three main formula. This is a bit related to ideal gas. So we are not going to use this formula. These three formulas are most important. As you can see, if you have to calculate the number of moles, uh, if the given mass, if the mass in grams is given, then you are supposed to use the first formula. In this formula, you divide the given mass, that should be in gram, by the molar mass. Molar mass is actually the molecular mass or the atomic mass of the element or molecule, but with the unit as gram. Now the second way to calculate the number of moles is when the number of particles are given. For example, if you have given quite like that, you say 12 into 10 to the power 23 molecules of oxygen, then you have to find the number of moles. Then you are supposed to divide this number by Avogadro's number, that is 6 into 10 to the power 23, and you get your answer as 2 mole. So this formula is used when the number of particles are given. So you divide the number of particles by the Avogadro's number, and Avogadro's number is denoted by Na, which is 6.022 into 10 to the power 23 entities or particles. The third most important formula is only for gases. So this formula is applicable when only gases are given. There is a very special case regarding gases. The case is all the gases at STP contains at STP occupies the same amount of volume. So 1 mole of any gas, 1 mole of any gas occupies 2.4 liters at STP. This is fixed. So when you have to calculate volume and when you have to calculate moles and the volume is given in liter, then you have to divide the given volume by 22.4 liter to get your answer in by of number of moles. Let us begin to our first question. And the question, it says that sum of number of protons, electrons, and neutrons in 12 gram of carbon is. So carbon atom is given, mass of carbon atom is given. So as earlier I have told you the formula for number of moles, the first formula we are going to use because the mass is given. So let us begin. So number of moles denoted by N is equal to given mass small m by molar mass. So small m, what is the given mass? It is 12 gram. 12 gram. What is the molar mass of carbon? It is 12. Molar mass of carbon is 12. 12 gram, 12 gram. Cancel out, you get your answer as 1 mole. So you have 1 mole of carbon atom. And if I talk about in one carbon atom, we have how many proton? In one carbon atom, we have 6 proton. Here you can see 6 proton is there. So 6 proton, and since it is neutral atom, it has 6 electron. And how you get the number of neutron? So by subtracting the mass number by atomic number, so 12 minus 6, you have 6 neutrons. So what are the sum of these all? Sum of these all comes to be 16 times 3 is 18 entities. 18 subatomic particles are there in carbon. So if one carbon atom contain 18, see, if one carbon atom contains 18 subatomic particles, then 1 mole of carbon atom must contain 18 mole subatomic particles, 18 mole electron, proton, neutron. So it's 18 times, what is 1 mole? 1 mole is equal to what? 6 into 10 to the power 23. Now you are supposed to multiply it. 8 6 48, carry 4, you have this much into 10 to the power 23. So which option is correct? You have the correct answer as option number C. C is correct. Now moving to the next question. The next question says the actual weight of a molecule of water. Actual weight. The weight in gram has been asked to us. So it is impossible, like H2O, one molecule of water is what? It is H2O. Sorry, it is H2O. So H2O is one molecule, and what is its molecular mass? Its molecular mass is 2 times the mass of hydrogen plus 1 times the mass of oxygen. So mass of hydrogen is 1 only, and mass of oxygen 16, so it is 18U. I think you know the calculation. So 18U is the mass of water. 18U is the mass of water, and I think if you know, 1U is equal to 1 by 6 into 10 to the power 23 gram. That is equal to 1.67 into 10 to the power minus 24 gram. So I'm going to use this data in my calculation because this is quite easy. The terms are likely to be cancelled out. So this much 18U is equal to 18 into 1U is going to be this much, 1 by 6 into 10 to the power minus 20 plus 23 gram. Calculating this, cancelling 18 by 3 times, I get as 3 into 10 to the power minus 23 gram as the mass of one molecule of water in grams, and that is the correct answer. 3, that is B is approximately equal to it, so B is the correct answer. Why not 18 gram? Because it is, one molecule of water cannot weigh 18 gram. 18 gram is, molar mass of water. That means 1 mole of H2O weighs 18 gram. 1 mole of H2O weighs 18 gram. Sorry. Now moving to the next question, we have the third question, which is element A and B forms two compound A2, B2A3, and this B2A. So these are the two compounds formed by A and B. Now, 0.05 moles of A2 B2A3 weighs 9 gram. This much weighs 9 gram, and 0.1 mole of B2A weighs 10 gram. Then we have to calculate the atomic mass of A and B. So let's suppose atomic mass of A be AU, A, and the atomic mass of B as a small b. So using this, I can calculate the molecular or the molar mass of B2A3. What is the molar mass? 2 times the mass of B plus 3 times the mass of A. And what is the molar mass of B2A? B2A molar mass is 2 times the mass of B plus 1 times the mass of A. And this is the molar mass we have calculated. Now the question says that what is the given mole of A2? A2. Now I'm talking about B2A3. B2A3. For B2A3, we have this much moles. How much mole? 0.05 mole. So 0.05 mole is going to, what is the formula? Given mass upon molecular mass. We have the formula for moles now. I am writing it over here. Moles is equal to given mass upon molecular mass. This is the formula I am using. So this much moles is equal to given mass. So what is the mass of for this much is given? It is 9 grams. So 9 by, what is the molecular mass of B2A3? It is 2B plus 3a. Now similarly I get the second equation by talking about B2A, and for the compound B2A, how much moles I have? 0.1 mole only. So I have 0.1 mole only. And how much mass is given? 10 gram. What is the molecular mass or the molar mass of it? B2A is 2b plus a. 2b plus a. Now through these two equations I'm supposed to substitute the value of a and b. So for this, what I can use? Now listen, see it carefully. For this I can write it as removing this and writing 100. Now 5 times 100 is 20. This comes, this goes here, this goes there, so we have 2b plus 3a comes to be 9 times 20 is 180. This is the first equation we have. Now from this 0.1 is what? 1 by 10 only, so 10 comes here. 100 is equal to, now 2b plus a is equal to 100. From here I get the value of 2b as 100 minus a. I'm going to substitute the value of 2b into this equation, into the first equation which we have. I'm writing it here, okay? So in this I'm writing it here. I'm supposed to substitute the value of 2b. So 2b is equal to 100 minus a plus 3a, going to be 180. So now 2a is going to be 80, a is going to be 40. So a, the molecular mass of a is going to be 40. So of that b, it is going to be 30 only. You can calculate by here. So 2b is equal to 100 times a, that is 40. 2b is 60. So we get b as 30. So the molecular mass of so the atomic mass of b is 30. So this is option C is our answer. Moving to the next question. The question is about the third formula which we have studied, and the formula is only applicable for gases. The formula is number of moles for any gas is equal to volume of the gas by molar volume of the gas, that is 22.4 at STP or NTP. So the question says, if VML of vapor of the vapors of substance at NTP vapors, any substance, we do not have to consider any gas because all the gases occupy the same volume at STP, same mole occupies same volume. So VML is occupied by W gram. Then the molecular weight of substances, let the molecular weight be M. Let the molecular weight be M. Now M, molecular weight. So I'm supposed to calculate moles in two cases. Moles is going to be what? Weight by molecular weight. So weight is given to us as W. So W by M is also moles, and again moles using the formula of volume, and volume is V divided by 22.4, and this formula is only applicable when the volume is in liter, but here the volume is in ml if you look carefully. So for that I have to convert this also into ml, and I have to multiply by 1000. So this is going to be V by 22400. Now since both are the moles, I can equate both equations to get W by M as V by 22400. So M is going to be M goes there, this comes there, so V also comes down, so it is going to be what? W times 22400 by V. W by V times 22400. Option A is the correct answer. Now moving ahead to the fifth question, which we have is this much molecules are removed from 98 gram of H2SO4. Then the number of moles of H2SO4 left are, so we have 98 gram H2SO4, and from this I subtracted how much molecules? This much molecule. And if I manipulate this in terms of moles, so it is going to be I'm going to use the formula is number of particles given by Avogadro's number. So this is going to be 3 into 10 to the power 20 by 6 into 10 to the power 23, and I'm going to get as 0.5 times 10 raised to the power minus 3. So this much moles, this much moles I'm supposed to subtract from this much moles. So it is 0.5 into 10 to the power minus 3 moles. So if I calculate this in moles, so 98 gram, what is the molar mass of H2SO4? H2SO4 stands for 2 hydrogen. H2SO4 stands for 2 hydrogen. 2 hydrogen plus 1 sulfur plus 4 oxygen. 2 hydrogen 2. What is the molecular mass? Atomic mass of sulfur. Atomic mass of sulfur is 32. 32 plus 4 times of oxygen is 16. 16 times 4 is 64. And now this is going to be 98 gram is the molecular mass. So 98 by 98 going to be 1 mole. 1 mole. So what is going to left is 1 mole minus 0.5 into 10 to the power minus 3 moles. This much is only going to left, moles. Then the number of moles. So if I calculate this, so if I calculate this, I get the answer as it is going to be, I carry out 10 raised to the power minus 3. So this is going to be a critical calculation. 10 raised to the power minus 3, I'm going to take out common. 1 by 1000, I'm going to take out common. So here remain 1000 minus 0.5. And to simplify the calculation, sorry, what has happened, I don't know. Yeah, now this is going to be, how much? So 1000 minus 0.5 is going to be 998. It is really 1000. Yeah, 1000. I can simply write it as this is 9.95 into 10 to the power. Yeah, we have made some mistake somewhere. I think minus 3. This here we have did well, minus 3, then 0.5 times minus 3, then this much moles I'm supposed to subtract from 1 mole. Sorry, yeah, here I have it. It is not gram, it is milligram. So to convert it into gram, I have to multiply by minus 3 gram, 10 raised to power minus 3. Sorry, yeah. So here we have made a small mistake. Let me correct it. Sorry, let me correct it. So it is how much? 98, not gram, milligram, 10 raised to power minus 3 by 98. This much moles I have. So this is going to be 10 raised to the power minus 3 mole. This much mole minus What is our answer? 0.5 into 10 raised to the power minus 3 mole. So I'm taking out 10 raised to the power minus 3 common. I'm left with 1 minus 0.5. So the answer is going to be 0.5 into 10 raised to the power minus 3 mole. 0.5, yeah, B is the correct answer. B. So these small things we are supposed to keep in mind. It is milligram, not gram. So moving to the next question, the question asks which has the highest mass. So 50 gram of iron, so mass is already given 50 gram. Now this 5 mole of N2. So we know the formula is N is equal to, moles is equal to given weight or mass in gram by the molar mass. So mass is going to be moles times molar mass. How much moles is given? 5 mole. So 5 times molar mass of N2, it is 2 times of that atomic mass of nitrogen, that is 14, so it is going to be 28. 2 times of 28, that is 140. 140. So 140 gram, this weighs 140 gram, so this is not going to be the answer. Now 0.1 mole atom of silver, Ag. Now if you remember silver's atomic mass, so silver has an atomic mass of 108. Silver has an atomic mass of 108. 108 U. So mole is already given, mass is equal to moles times molecular mass. This formula I am going to apply. So this formula, how much moles is given? 0.1 mole times 108, going to be 10.8 gram. It is also not the highest. And now this much atoms of carbon, 10 raised to about 23 atoms of carbon. First I'm going to convert into what? Moles. So moles is coming out to be 10 raised to the power 23 by, I will get those number 10 6, 10 raised to the power 23 cancel out to give us 1 by 6 mole. So the mass is going to be moles, that is 1 by 6 times what is the atomic mass of carbon? 12. It is going to be 2 gram. So B is the correct answer. It has the highest marks. Sorry, mass, not marks. Mass. Highest marks. 5 moles of nitrogen has the highest. Yes. 5 into 28, 140. Moving to the next question. Question says hemoglobin contains this much of iron by weight. The molecular weight of hemoglobin is approximately this much. The number of iron atom is itna. The number of iron atoms, the atomic weight of my iron is given, present in the one molecule of, number of iron atoms present in one molecule of hemoglobin. This is a quite tricky question, so we need to be careful while solving this. The question says hemoglobin contains this much percent of iron by weight. Weight is important, so I'm supposed to calculate weight first. So weight, the molecular weight of hemoglobin is approximately this, the number of iron present in one molecule of hemoglobin. What is the atomic molecular weight of one molecular weight means what? Mass of one molecule. So mass of one molecule of hemoglobin is this much. Is how much? 67200 U. And now about this 0.33%, that is what? 33 by 100. 0.33 by 100. This is going to be give us this much. If I'm not wrong. And this is approximately 1 by 300. So 1 by 300 part of hemoglobin is iron only, so this multiplied by 1 by 300 is going to give us the weight of iron in it. So what is the weight of iron? Weight of iron is going iron is going to be what? 67200 times of 1 by 300. This much is going to the weight of iron. So cancelling out, I'll get the answer as 2. This is the weight of iron, and one and the mass of weight of one molecule, one atom, one iron atom is given to us as 56 U. So in this much, how many atoms are there? How we are going to find? By dividing the mass of iron by the atomic mass, and this is going to be approximately 4 iron. C is the correct answer. 4 iron atoms are there in one molecule of hemoglobin. This can very easily be calculated using the very simple method is there. We haven't used any formula of mole concept here in this question. Very good question it is. Now the next question is, Na is Avogadro's number. Then number of valence electron in 4.2 gram of nitride ion is. Then the number of valence electrons has been asked to us in 4.2 gram of nitride ion. So nitride ion, we are given with nitride ion N3 minus. So if you look carefully in nitride ion, we have how many valence electron? In nitride ion we have, what is the electronic configuration of nitrogen? Is nitrogen 7, so 2 comma 5. Now in order to complete its octet, it has taken 3 more electron. Like this, it has 3 minus charge on it. So the valence electron in this case is going to be how much? 8 electron. For this nitride ion, valence electron is 8 electron. Now in this much gram of nitride ion, I have to find the, so what is the mass of nitride ion? As the mass of nitrogen, what is the mass of nitrogen? 14 gram. Molar mass of one atom of nitrogen, sorry, molar mass of nitrogen. So now I'm going to calculate mole using the formula given mass, that is 4.2 by, I'm going to divide by molar mass, and molar mass is 14 only. This is going to give me the mole. So how much it is? 6.6 by 10, 6 to 3.3 mole. Now I have 0.3 mole nitride ion, and in one nitride ion I have 8 electron. So in this much moles, how many valence electron I am going to have? Valence electron is equal to 8 times 0.3 in mole is the number of valence electron. Now 2.4 mole is the answer, and if this much mole is there, so I can write it as 2.4 Na. That means 2.4 Na molecules. 2.4 Na molecules I have. Na electron, sorry, not molecules, electron, particles we can say. So A is the correct answer. Moving to the next question is, an oxide of metal has 40% by mass of oxygen. Metal has an atomic mass of 24. The empirical formula of oxide is. Nice question. The question says, empirical formula of oxide, and the mass percentage is given 40% by mass of oxygen. Mass percentage of oxygen is given as 40%. So I can get 40% by dividing what? So 40% is going to be the mass of, has an atomic mass of 24. If let's say the formula of metal oxide be MXOY, let this be the formula. MXOY be the formula of the metal oxide. MXOY Oh, that means I have y number of atoms of metal, sorry, x number of atoms of metal and y number of atoms of oxygen in one molecule of the metal oxide. So what is the here it is given as the 40% by mass of oxygen, 40%. So 40 by 100 of oxygen, how many oxygen? Y oxygen, y times of 16. This is the total mass of oxygen in one molecule. By now I have calculated total mass of oxygen. I have calculated. Now what is the total mass of the entire molecule? So x times the mass of 24 plus y times the mass of oxygen, that is 16. So 24x plus 16y. Next I have, if 40% I have oxygen, then the remaining 60% must be the metal. Metal is x times of 24 by the total mass, again 24x plus 16y. Now if this is same, now this portion is same, I can compare both the equations. So I can simply divide one equation 1 by equation 2, equation 1 divided by equation 2. If I divide, I'll get the answer as this 100 will cancel, this 100, the 0 will cancel, 0. I have 4 by 6 going to be, this will cancel, this are going to be 16y by 24x. Now if I cancel this, so 4 times 4 is 16, 6 times 4 is x, and if I cancel 4 by 4, so we have x by y, sorry, I have x by y as 1 by y, 1 by 1. And if this is x by y is 1 by 1, then the empirical formula is definitely going to be MO, because x is going to be 1, O is going to be 1. MO is the correct answer. C is the correct answer. Moving to the next question, we have caffeine has a molecular weight of 94. Caffeine, I think caffeine is there in coffee and many other carbonated drinks. Caffeine is used to give you instant energy, but it is very harmful, injurious to your health. Now looking at the question, the question says we have caffeine. We have given the molecular weight of caffeine is 194 molecular weight of caffeine. It contains 28.9% mass of nitrogen. Now again the same question as of hemoglobin. Number of atoms of nitrogen in one molecule of it is very same question, I would say. So 28.9% of 194. 194 is the mass of one molecule of caffeine. अब एक molecule caffeine का इतना percent mass of nitrogen होगा in that caffeine. So this is going to be total mass of nitrogen. Mass of nitrogen. So 28.9 is, let's say 29 only, or we can approximate it as 30 in chemistry. All these things we can do. So 30%, that is 30 by 100 into 194. This is going to be the mass of nitrogen, and if this is mass of nitrogen, I'm supposed to divide this number. By the mass of nitrogen, that is 14, and 14. So this is going to be the number. Approximately I have to cancel out. So there is no, so I'm going to cancel out. It can very easily be cancelled in a very simple way. I can cancel it as this. I can approximate to 200. Yes, or leave it. Now this 1 times 14, then 54 is 28. 3 times, approximately in 3 times I'm going to cancel this also. And 13 into 3, 39 by 10. I can approximate 39 is 4. 40 by 10 is going to be give us 4. So I have 4 molecules. C is the correct answer. Or we can check also. We can check also. I can write here as, what is the number of atoms of nitrogen? Sorry, number of atoms of nitrogen in one molecule of caffeine, CAFFINE, caffeine. One number of atoms of nitrogen in one molecule. There are 3 nitrogen atoms in one molecule, in one atom of caffeine. Excuse me. Then am I making some mistake? But as per my calculation, the answer is going to be 4 no. Let me check it. Let me check the calculation. Sorry. So I have 28.9 divided by 100 times 194. 194 divided by 14. This is going to be 4 only, so 4 is the correct answer. As per, if this is hypothetical, then also 4 is going to be the correct answer. Moving to the next question, question number 11. Okay, this is about the end. We have only 10 questions, so yeah, this is the end. Thank you and have a wonderful day.